Let's analyze the convergence of the infinite series sum of sine of n pi over 2 divided by n factorial, where n goes from 1 to infinity. To test this series, let's first understand the pattern of sine of n pi over 2. When n equals 1, we get sine of pi over 2, which equals 1. When n equals 2, we get sine of pi, which equals 0. When n equals 3, we get sine of 3 pi over 2, which equals negative 1. When n equals 4, we get sine of 2 pi, which equals 0. This pattern repeats every 4 terms. So our series can be written as sine of pi over 2 over 1 factorial plus sine of pi over 2 factorial plus sine of 3 pi over 2 over 3 factorial plus sine of 2 pi over 4 factorial, and so on. Now let's look at the actual terms of our series. The first few terms are 1 over 1 factorial, which is 1. 0 over 2 factorial, which is 0. Negative 1 over 3 factorial, which is negative 1/6. 0 over 4 factorial, which is 0. 1 over 5 factorial, which is 1 over 120. To test for convergence, we can use the ratio test. Let's call our general term a sub n equals sine of n pi over 2 divided by n factorial. For the ratio test, we look at the limit as n approaches infinity of the absolute value of a sub n plus 1 over a sub n. This gives us the absolute value of sine of n plus 1 pi over 2 times n factorial divided by sine of n pi over 2 times n plus 1 factorial. Simplifying this, we get 1 over n plus 1 because the sine terms are either 0, 1, or negative 1, and their ratio will always be 1 or negative 1 in absolute value. Since this limit equals 0, which is less than 1 by the ratio test, our series converges absolutely. Therefore, the series converges. In fact, we can see that the terms get very small very quickly due to the factorial in the denominator, which grows much faster than any oscillation in the numerator.